Okay. First, let's talk about the relationship with secant, cosecant, and sine and cosine. Okay. So what do we know about secant and cosecant? They're reciprocals. Okay. So what is the reciprocal of cosine? Secant. What is the reciprocal of sine? Okay. If you can't remember that, write it down. Okay. Secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. Okay, so let's think about what reciprocal means. Okay. In your own words, turn to your neighbor and describe what you do when I say take the reciprocal. Connor, what did you and your partner say?
So it's not going to be academic at all, but I flip it.
You flip it. Okay? That's exactly what, okay, you take a fraction and you flip it, right? I mean, it maybe doesn't sound professional, right? But it's what we think of doing, okay? We take a fraction and we flip it, okay? So if our cosine value is 1/2, then our secant value is 2. If our sine value is radical 2/2, then our cosecant value is radical 2. Okay? Now, where it becomes interesting is when we have to take the reciprocal of 0. What happens when we take the reciprocal of 0? Undefined. And on a graph, how do we represent undefined values? Okay. Darby said whole. Jackson said asymptote. Which one? Okay. Wholes happen when we cross something out. If I just give you secant of x, there's not going to be like any factors to cancel out. So what's happening is there is an asymptote. Okay? So when we have an undefined value, that's where we're going to place a vertical asymptote. Okay? So your secant and cosecant graphs will have asymptotes. Okay, so what we're going to do is we're going to construct the secant and cosecant parent function graph based on our sine and cosine parent function graph. Okay? And basically, when I ask you to graph a secant or cosecant graph, you're going to graph its reciprocal and then draw in the actual curve with the asymptotes. Okay? So, what I'd like you to do is very nicely graph y equals sine of x. With my blue marker, I'm going to draw the cosecant curve, really blue and red. Okay. So, we decided that the reciprocal of 0 was undefined, and graphically that meant we were going to have a vertical asymptote. Well, I see in this one period of y equals sine 3 places where the sign is 0. which means we are going to have 3 vertical asymptotes in our cosecant graph. And we'll just get in the habit. These are things you're going to have to label on your graph, okay? So our parent function has vertical asymptote is at x equals 0, x equals pi, and x equals 2 pi. Right? Then we need to take all of these values and find their reciprocal. Okay? So here, the sine value is 1. What's the reciprocal of 1? 1. Okay, so we're actually going to have a coordinate right there. Okay. Here, the sine value is 1/2. What's the reciprocal? Okay. Same thing's going to happen over here when we're 1/2. So what's going to happen is we have these U-shape, this U-shape that shares a point with y equals sine, where sine is 1, but then it's going to open up and approach those asymptotes. Okay. Same thing is going to happen down here. The sine of 3 pi over 2 is -1. If we take the reciprocal of -1, we get -1. So that point is still going to be a coordinate for cosecant, but then all of these, when we take the reciprocal, we're going to get these values that create that U-shaped curve now opening down, approaching those asymptotes. Okay. So when we graphed sine, there were 5 critical points that I made you label, correct? Okay. Now, when we draw the reciprocal, we still have 5 critical items that we need to consider in our graph, okay? In this case, we have 1, 2, 3 asymptotes that occur, and then you would want to label these 2 points here. What we're going to do if we have any sort of transformations on our cosecant curve is we will draw a frame and lightly sketch in the sine curve in that frame, and then draw in our asymptotes and U-shapes. Okay. All right. Let's go ahead and create a secant graph. So if you would, lightly sketch the cosine curve. So this process is going to go very similarly. We're going to look at where our cosine is 0. That happens at pi over 2 and 3 pi over 2. That is where we are going to have our vertical asymptotes. And then since sine and cosine have very similar shapes, secant and cosecant will have similar shapes. Okay? Here where the cosine is -1, the secant would also then be -1. And then we would draw our U shape down. Here where the cosine is 1, our secant would also be 1. We know that those U's have to approach those asymptotes. Now technically there is an entire U shape here, and then in the period before this one that we have graphed, there would be an asymptote here at -π/2. Now, technically for one full period, we would only have like that half of a U. If it bothers you and you want to draw the entire U, that is not going to bother me at all. Okay? Same thing happens over here at 2π where cosine is 1, secant is also 1. So we're going to draw that U approaching the vertical asymptote. If it bothers you and you want to draw the entire U, not a problem. Technically though, this would be the one full period. Okay. So same thing goes for secant. We're going to sketch a frame and think of the cosine curve so we know where to put in our asymptotes and U's. Okay? Still 5 critical items here in our cosecant graph. This time 2 asymptotes and 3 points where we would label those U's. Okay? So let's see if we can get one graph in before lunch here. Go ahead and write this down. We are still going to identify period and starting point. The secant and cosecant graphs do not have amplitude. Sine and cosine have amplitude because they're waves. All right, secant and cosecant aren't waves, so there's not an amplitude, but we'll just identify A so we know how to draw our frame. Okay, so I'm going to just write that the absolute value of A is 2, and we have a reflected graph. Okay. The period would then be what, Will? Okay, 2π. Our B is 1, so we have 2π divided by 1. And then our starting point, since B is 1, would be what, Marley?
-π, -2.
Ooh, -π, -2. Very good. Remember, this is Bx minus C, so our starting point is -π, -2. Okay. So our starting point is -π, -2. Our A value is -2. So we're going to draw our frame up to 0 and down to -4, just like we would with a sine curve. And then our period is 2π. If we begin at -π and the period is like 2π, where are we stopping? Ah, that one's nice, isn't it? Okay. Okay. So halfway between -π and π would be what? 0. Halfway between 0 and π is π/2. And halfway between -π and 0 is -π/2. We'd be really happy if we had problems like that all the time, right? Okay, so this is what I'm going to do. When I draw things in green, that means I'm drawing them really lightly. So what I'm going to do is I'm going to very lightly draw in a sine curve that has been reflected. Okay, first of all, we're going to graph a cosecant. Its reciprocal is sine. And we have a reflected graph. So I'm going to very lightly draw in a reflected sine curve. Then what we will do is draw in our asymptotes and our u's, okay? Now, on the parent function, our asymptotes occur where our sine is 0. Since this has been transformed, okay, we are going to keep it with where our asymptotes get shifted around too, all right? So we're just going to look at wherever we have a coordinate that hits the middle of our frame. That would be where the x-axis used to be, but then we've been shifted all around. Okay, so this is where we are going to get our asymptotes. And just like with our other curves, I make you label those 5 critical points. So in this case, we're going to label these 3 asymptotes, which we already know where they are. So this is x equals negative pi, x equals 0, and x equals pi. Okay. Then we're going to take any points on the top or bottom edge of our frame, and we're going to draw the u's. So here, this coordinate, which we typically label, so in this case, negative pi over 2, negative 4, we're going to label that point and then draw our U shape. Same thing up here. This is a critical point. Pi over 2, 0. We're going to draw the point and then draw on our U's. If you can draw a sine curve, you can draw a cosecant curve. Okay? It's basically 2 extra steps. Draw your sine curve, and then draw on your asymptotes, draw on your u's. Okay? Now, here's where it gets interesting. The domain and range. The domain of this function. Is the domain all real numbers? No. What is breaking up the domain of this function? Asymptotes. And our asymptotes happen every consistent length, right? So in this case, they're happening every pi. But in a different graph, they may be happening every 2 pi. In a different graph, they may be happening every pi over 4. It is going to be too complicated to write the domain for these graphs, so I'm not going to ask you to do it. We do not have to identify the domain of secant and cosecant graphs because it's so broken up. Okay. However, I will ask you to identify the range. Okay. Remember, our curve is in blue. Okay. Would anyone like to take a shot at identifying the range? Jackson?
Parentheses, negative infinity, comma, negative 4, bracket, U, bracket, 0, comma, positive infinity.
Okay, very good. We have blue curve below and above our frame. So we have from negative infinity until this point, negative 4, and then we have blue curve again at 0 and above. Okay, So it's basically going to be the opposite of what we would have for sine. Our sine curve has range -4 to 0 in this case. And so our cosecant curve is just going to have the outside intervals. Okay? It's time for lunch. When you come back, we will graph a secant curve that has been transformed. Next up, we have a secant graph. Please go ahead and write this down. Then I would like you to identify the period and starting point. Let's see. Ben, what's our A value?
It'd be, 1.
Okay, good. The period, what did you get, Kelsey?
I have 2 pi over 2, which is
2 pi over 2, which is pi. Do you agree with Kelsey?
Yes.
Yes. Okay. And then our starting point. What do you have, Amanda?
I have
Negative what?
negative
Negative pi, comma, 2. Do you agree with Amanda? Yes? No? Brian, what do you disagree with?
Can it be -5 over 2?
Well, let's see. We have c divided by b for our x coordinate, right? Our c coordinate, or our c value is negative pi over 2, and we're dividing by b, which is 2. So isn't this pi over 4? Okay. So our starting point is negative pi over 4, 2. We'll go up 1 to 3 and down 1 to 1. Okay. We begin at negative pi over 4. Our period has length pi. So when we add pi to negative pi over 4, that means we're stopping where? 3 pi over 4. Okay? Halfway between negative pi over 4 and 3 pi over 4. Pi over 4. Here's a nice one. Halfway between negative pi over 4 and pi over 4. 0. And then halfway between pi over 4 and 3 pi over 4. Pi over 2. Okay. So very lightly, some of you may not even have to do this. Some of you can visualize it in your head and then draw it out, and that is fine. But if you're going to draw it very lightly because it's not actually a part of the curve. Since we're drawing secant, we need to imagine a positive cosine graph. Okay? So very lightly, you can draw in a positive cosine graph. And if you want to visualize it in your head and not draw it, that's fine too. Okay. All right. Now we need to take any place where our curve hits this center line in our frame, and that is where we are going to draw in our asymptotes. So we will have asymptotes at x equals 0, and here again at x equals pi over 2. Okay, then we'll draw in our u's. So this one right here, we have a point at pi over 4, 1, and we'll draw our u down, approaching the asymptotes. Here we have a point at negative pi over 4, 3, and we'll draw in our u, or half of the u, whichever you prefer. And then we have another point here at 3 pi over 4, 3, and we'll draw that u in. Okay. Technically, this green cosine curve isn't a part of the curve. We just use it to help us get the asymptotes and coordinates that we need. Okay, so either draw it in lightly or imagine it, whichever one works for you. What's nice about secant and cosecant is it's just really another way to practice cosine and sine with just another step. Any questions about secant and cosecant before we continue the tangent? Okay. So, we are going to construct y equals tangent of x. All right. Let's start at 0. What's the tangent at 0? Zero. Thank you. What is the tangent? Well, pick an easy one at pi over 4. 1. Well, then what happens at pi over 2? Our tangent is undefined. So what's happening at pi over 2 on our tangent graph? We have an asymptote. Okay. All right. Now, let's go ahead and figure out what's happening to the left of 0. Okay, we kind of stopped at an asymptote, and we can keep going. All right, but let's figure out what's going on over here. So if I rotate down to like negative pi over 4, what's our tangent value? Say it. Negative 1. And if we rotate to negative pi over 2, what's our tangent value? Undefined. This is our tangent graph. You've seen it before? Okay? And what happens is this is going to keep repeating. So this is like the one period that we are going to focus on, but then it is going to repeat, okay, every period. We're just going to have all of these stakes in between asymptotes. Just to me what that looks like. Okay? Now, big difference that we need to understand. What is the distance between the asymptotes? Pi. Tangent has period pi. Also, is the tangent curve a wave? Yes or no? No. Therefore, this also does not have amplitude. Okay? The A will be important, but tangent does not have amplitude. So I have another handout for you, because we're going to use the framing method again, but the tangent frame is much, saving actually.
You'll get this on the back.
It is, and so some people were taking them in. Okay. So, what I want you to notice here, on our parent functions for sine and cosine, 0, 0 is like our starting point, right? And then we drew our frame. Here in tangent, 0, 0 is smack dab in the middle of that frame. Okay? So for your tangent graphs, your starting point is now going to be in the middle of your frame. So what I want you to do on your sheet is go ahead and break this up into the same fourths. But what I need you to do is put a coordinate right there and label it as that's your starting point.
Do we have some sheets for you?
Oh, come on, yeah. I get so excited about tangent graphs. Okay, so since the starting point, and it says this in step 3, okay? In step 3, it says the starting point should be in the middle of your frame, okay? Now, we're still going to use the A to determine the frame, all right? So we're still going to draw our frame up A and down A. We just can't call it amplitude because it's a tangent graph. Okay? You are going to have vertical asymptotes, and those are going to be on the very edge of your frame. So wherever your frame starts and stops, that is where your asymptotes are going to be. I'll put that down here somewhere. Okay. Now, on your blue sheet, if you go to 1B, it says calculate the period. Since our tangent graph has a period of pi, then we're going to calculate the period by using pi divided by b instead of 2 pi divided by b. Okay? This is only for tangent and cotangent if we were going to graph it, but we will not. All right, so coming back to constructing our frame, you'll see in 3C, use the period to determine the length. That's not new, but since our starting point is in the middle, we're going to have to put half of the period to the right of our starting point and half of the period to the left of our starting point. Okay, so we're going to have to think about our period and put half on one side, half on the other. all right, for a total length of pi divided by b. Okay? Then what you will do is for, this is a tangent with a positive a, you'll put a point on the edge up at this quarter mark, and you'll put a point down here at this quarter mark, and you will draw in your curve. For our negative a tangent graph, it will be the opposite. The left will have the higher point than the right. Make sure that you go to the quarter mark on the edge of the frame, and then draw your curve approaching the asymptotes. If I were you, I would put a star by 3b, half of each period on each side. I would put a star there for when you're doing your homework tonight and studying for your quiz Wednesday. All right, one example. Are you ready? Okay. Tangent does not have amplitude. If I ask you for the amplitude, you will write none. But it's important that we recognize that our a value is 2. The period for a tangent graph is pi divided by b. In this case, b is 1. So pi divided by 1 is pi. Our starting point is still c divided by b comma d. That has not changed. In this case, there is not a c. So it's 0. 0 divided by b is 0. And then our vertical shift is 3. So our starting point is 0, 3. All right. So our starting point is 0, 3. We know that is one of our critical points. Okay. In order to draw this frame, start from the starting point, and we're always going to go up A and down A. So we're still going to go up 2 until we reach 5, and down 2 until we reach 1. Now the difference is we put half a period on each side of our starting point. So since our period is length pi, when we cut it in half, that would be pi over 2. Okay? So we are going to go to the right pi over 2. And to the left pi over 2. And then we will still make our quarter marks just like normal. I think it's easiest to draw the asymptotes first, so then you know where to put your curve. Your asymptotes are going to go on the edges. So here's an edge. I'm going to draw in an asymptote. And label it. It's one of your 5 critical items that you need to label. And then this edge over here is also an asymptote. Then the top and bottom edge of your frame, that's how you know where these coordinates are. If you do not have these coordinates correctly labeled on your graph, you will not get full credit. You can't just draw in a curve and say, hey, there's my tangent graph. I have to know that this coordinate right here is pi over 4, 5, and I need to know that this coordinate right here is negative pi over 4, 1. And then you can draw in your curve. Like I said a couple days ago, you can label the points and asymptotes on your graph, or you can label them off to the side. It does not matter, but I need them labeled. Each graph we have done has 5 things you need to label. Either 5 points, or a combination of 5 points and asymptotes. Any questions about tangents? You will have a tangent graph on your quiz and your problem set. Okay? Which is why it is vital and on your test. Okay? Which is why it is vital that you do your homework. 1, 2, 3, 4, 5, 6, 7. There are 7 problems in your homework. And of those 7, 1, 2, 3, 4, 5 of them are underlined. Okay? So bare minimum, you need to do 5 graphs this evening.